Howdy again, it's Mr. Pete, and this is part 4 of my 4-part series on making a cutaway and demonstrating the Ford 1930 Model A 3-speed transmission. So it's pretty much done, and the purpose of this chapter, the final chapter, is to talk about the different gear ratios and the different positions and so on, the purpose and the flow of power through the transmission. I hope you watched the first 3 parts, or this may mean nothing to you. Thanks for watching. If you like this kind of content, give me a thumbs up. Be sure and watch the extra credit for lots of still pictures and a real good blooper of what just happened here. So, I think the project turned out pretty well. I went from this in part 1 to this in part 4, about 2 weeks in the making. Hope you enjoy it, as I said before. Now, this is a 1930s, actually design made in the 1920s, so it's pretty archaic, and is sometimes called a sliding gear transmission. It uses strictly straight gears or spur gears, which is very noisy compared to modern helical gears, and the entire case can be relatively short because the helical gears are usually a little wider, and there has to be thrust bearings in here. So we have none of that in this older design, and this was a very typical design. Even though Ford has a patent on it, I think the basic design goes back much farther than 1925, let's say. I would estimate that the majority of Americans have never driven a car with a manual transmission and a clutch. So this is probably of no interest to you. You have automatic transmissions that are actually much better and much easier to drive. And of course, electric cars will have no transmissions at all because the motors have great torque at all speeds and can be easily reversed. So a transmission probably is a total thing of the past, except for performance people who like the hot rod. I'm not really sure how much 90 weight oil this would hold, but I'm holding the cutout here in the approximate original position, and you can see that the filler here, and you would put enough oil in there just to come up almost to the top, and that is right about here. So I think this holds a pint or 2 of 90 weight, and it would leak like crazy. I think I said that before. Remember, when you were checking these underneath these old cars, there was no light and you didn't jack it up. You just took the plug off, you're laying on your back, and you would check it with your pinky finger to make sure there was some black oil on it. Same thing with the rear ends. For this demonstration, I have a Rube Goldberg setup here with a Milwaukee drill, and I got a foot switch which you cannot see. This is a variable speed, but certainly the torque is varying here depending on what gear that I have it in. I was considering painting the inside of this housing, this casting, white, and it might have shown up a little bit better. I also considered a dark red, which you often see inside castings, or brown, but was too lazy to do that, so it's just raw cast iron on the inside, but I think it still shows up fairly well. Let's go over these gears real quickly. I've done that in other chapters of this video, but this is the main drive gear right here. These are sliding gears here, and this one is for first and reverse. This one is for second and third. The bottom set of gears, all one casting, is called the cluster gear, and I'll explain those as I go along, but that has been covered before. So we have 3 speeds, reverse and neutral, all controlled by the shift lever out of the frame here through the shifting forks. Why do we need a transmission in the first place? Because gasoline engines have very little torque at low speeds. We have to get them up to around 3,000 or 4,000 RPM, at least in modern engines, probably less in the Model A. And then we have the power delivered to the rear wheels in the correct ratio so that you can go up a hill with a load and not have to shift down and so on. If you haven't driven a manual transmission, you probably are unaware of all that because your automatic transmission is doing that for you. You can feel it shift sometime if you're observant. And on the back side of the transmission, I cut away a window here so that you could see the reverse idler gear. The transmission is presently in neutral position. Notice that the two sliding gears are not in contact with gears below them, and when I push the pedal and start it here, you can see that the red propeller is not turning. Now the lower gears here, the cluster gears, are turning, as is that reverse gear back there, but they're just going along for the ride. They are doing absolutely nothing. The car would not move. So let me shift the transmission into low or first gear. Right there. And now I'll turn it on. And the flow of power is from the main drive gear down here, and now the cluster gear is moving, and this is the first and reverse gear. It is revolving, so take a look. That is the direction, the flow of the power. And notice how much faster the green propeller is going than the red one. And I'm going to show you all the gear ratios on the screen here in a minute. The transmission is in first gear. The ratio is 3.12 to 1. That's about a 3 to 1 ratio. So for each 3 revolutions of the engine, the output shaft will revolve only 1. That's 1, 2, 3. I'm back in neutral, and I will shift it to second gear. Did you see that the sliding gears moved, and now the power is going to go from the main drive gear down into the cluster gear, through this gear, on up, and out to the rear end. And notice the speeds of the propellers. Now watch what happens as I shift it into high or third gear. Did you see what happened here? Actually, the action is in here where it's a bit of a spline gear, really, that connects this main gear with this shaft, and the power is going straight through the transmission in a 1-to-1 ratio. The bottom gears, the cluster gears, are going along for the ride, which is a waste as far as friction is concerned. And the propellers are moving at the same speed. So it's straight through for high in almost all cars, unless they have an overdrive. Since there are no synchronizers in this transmission, you have to be at a dead stop to put it in low and reverse. So I'm back in neutral, and I'm going to put it into reverse. Right there. And this is a little bit more difficult to see, but again, the power is going down here through the cluster gear and up this way into this reversing gear, which is also first gear. And what you can't see is that power is being transmitted through that reverse idler gear, and that is what reverses the transmission in opposite direction, and basically low gear for that matter. The transmission is still in reverse gear. Now here's a bit of an illusion. Actually, it's not an illusion, but it might be hard to understand. But these two gears are not engaged and are not touching one another. Here's a piece of typing paper, and that will fit between the two gears. Now there's not much clearance there. It's just 3 or 4 thousandths. I couldn't even get a machinist ruler in there. But what happens here is that when the clutch is let out, again the power going through the cluster gear, and then the idler gear back there is engaged with this gear, and then it's transmitting the power back to this gear and out the back of the transmission. And that's how we get reverse. Perhaps now you can better see the reverse idler gear back here. Remember that these two gears are not touching one another. I'm not totally sure how well I explained that, so I'm going through it again using transparencies. I do not have the ability to do fancy animation like some of the better creators, so I'm doing it the way teachers would have done it in 1942. I'm still in neutral, and if you follow the arrows there from the engine and through the clutch, the cluster gear is turning, doing absolutely nothing, and it's a dead end. That's neutral. Okay, the gearbox is now in first gear or low, and look at the ratio, 3.12 to 1, and follow the arrows here to see how the power is flowing to the rear end of the car. Let me turn it on. At about 10 miles an hour, the gearbox can be shifted into second gear, and look at the ratio there, it's 1.85 to 1, and the flow of power through the second gear. At about 20 miles an hour, the car is shifted into high gear, which is a 1-to-1 ratio, and the power is going straight through. Remember, that cluster gear on the bottom is just going along for the fun of it. Okay, I've shifted the gears into reverse. Notice the ratio there. You can go a little slower if you're in a slow race with a Model A in reverse than in first. And look at the flow of power. But of course you cannot see that reverse idler gear in the back. It would do no good for me to put the camera back there because it's always rotating. But remember what I told you about the spacing between these gears here in the front. They are not driving at all in reverse. Okay, watch me shift through all three gears under power, which is not correct. First gear, second gear, and third gear. And reverse. Okay, here's the pop quiz that I promised, and I'm going to position the transmission without running it in the 5 different positions, and this number here refers to the question number, not the gear number or first gear or anything like that, and then the answers will be at the end. So what gear am I in for question 1? This is question 2. What gear am I in? I'm not going to run it. This is question 3. What gear am I in? This is question 4. What gear position am I in? This is question 5, the final question in the pop quiz. What gear am I presently in? Okay, here are the answers. Here's the answer to the pop quiz. Pause your video if you need to. Well, I think the project turned out pretty well. Remember, I started in part 1 with another transmission that looked just like this, and this is... I wasn't going to take this tranny apart again, but I thought I would to explain third gear or direct drive or high, whatever you want to call it, that now we do not need all of the other gears. The power goes straight through from the engine and clutch to the output shaft, and a 1-to-1 ratio. This gear is necessary, and this gear is necessary, and now I'll take those apart and show you why. With this gear pulled out, it no longer engages with the other one, and now the two separate shafts are spinning separately. They are not connected. This is the connecting gear or connecting link. Let me take that apart and show you how that works. Okay, this is the second and third gear. Slides on the spline. Notice the gear on the inside. In a way, it's not even a gear. It's more of a spline, because on the main drive gear, on the input shaft here, this looks like a regular spur gear right here, but they've shaved it down, so in fact it looks a little bit more like a spline, doesn't it? So when you put it into high, they simply connect with one another like that. And there must be a lot of clashing, because that really is badly worn. So as simple as it is, that is how third or high gear works. The transmission is in reverse in this patent drawing. Notice that these two gears are not in mesh. They are clearing one another just by a little bit, but the reverse gear and this gear are constantly in mesh, and right now in reverse the power is going up to the main shaft. The shop dog's here. Hi, Finn. Well, that concludes this 4-part series on the Model A transmission and how to make a cutaway. Remember that I have many what makes it work videos. I think I'll put the link to that down in the description if you like that type of content. Hope you enjoy my videos, and be sure and watch 1,200 other shop videos. This is Mr. Pete saying so long for now. Boy, that air feels good. It's 90 degrees today. Clean up, time to put your tools away.